All right, my name is E.J. Daigle, Dean of Robotics and Manufacturing here at Dunwoody College, and I'm going to give you a little bit of an introduction to the Siemens S7-1200 PLC. For most of you watching this video, you're coming at this from previously working with the Allen Bradley RS500 platform. So as you do, you'll notice some similarities, but you'll definitely notice some differences between Allen Bradley and Siemens. As far as general PLC functionality, things like timers and counters and compare instructions and math instructions, most of that stuff is going to be similar. As far as some of the syntax and the data types and things like that, some of that will be different. So things like 16-bit words will be replaced by 32 bits, and you'll see some bigger numbers and some smaller numbers and some time bases that are different. But overall, it's going to be fairly easy to pick up on. All right, so first and foremost, let's talk about what the S7-1200 modules look like. The first thing that we look at is this would be our CPU, and then these would be expansion modules that you would see on your CPU if you're working with a S7-1200. We can also add some communication modules on this side. In the lab for us, though, it's going to be a little bit different. This slot 1 for us will be the only slot that we'll really be using. That will house our CPU 1214C, which is an AC DC relay CPU. And so what does that mean to you? Well, first of all, when I talk about AC DC relay, this is actually important. You can get DC DC DC, you can get AC DC relay, you can get AC DC DC or DC DC DC. So you can get all kinds of different varieties of this type of CPU. That first term corresponds to the power of the CPU. What that means is to power this thing up, I need 120 volts, AC 60 hertz. And the second one, the DC, corresponds to DC inputs. So that means the inputs on this CPU are going to be 24 volts DC. The RLY, as you might have guessed, corresponds to the outputs being relay outputs. So again, most of what we do are going to be on this slot 1, which will be AC-DC relay. So we'll use the DC inputs on this module, the relay outputs. We do have an analog module that kind of plugs into this port, this number 4 right here. That'll be our analog module that we'll use in some of the job sheets. And then for us, next to the CPU, we actually have an Ethernet switch. So this Ethernet switch allows us to plug in things like our HMI, motor drive, PLC, our PC, so we don't have to constantly be changing cables as we're talking from this one to the next one. We can just do it all over one thing. So again, as you look at what you could do with this is how it is at Dunwoody. We've got our Ethernet and we've got our CPU. That's really all you're going to see. But in the real world, we could have up to 3 communication modules, which would go this way from the CPU. We obviously would have our CPU, the CPU Ethernet port, which resides right here, as it does on ours. The signal board, communication board, or battery, that's what can go in this slot 4 here. For us, we're using an analog signal board. It's a little expansion board that plugs right into the CPU. And then we can have up to 8 expansion modules that are going to go off in this direction that will plug into the CPU. So these could be like additional digital inputs, additional digital outputs, additional analog inputs, additional analog outputs. So lots and lots of different modules that can plug into this CPU. All right, the S7-1200 network. What are we actually talking about? Well, anything that plugs into the CPU, your expansion modules, communication modules, all communicate through the CPU. However, this Ethernet port, what it's going to do is it's going to run over to our Ethernet switch. So we have a switch right here, and that Ethernet port is going to plug in to the Ethernet port on the switch. We also will have an Ethernet port on this switch that'll plug in to an HMI. So you've got your PLC and your HMI, and then an additional Ethernet port that will plug in to your PC. So over here you'll have your PC with your programming software, and you'll actually be writing the code that you're going to use on the PLC. So the nice thing is no more hot swapping cables, no more plugging in a 232 cable here, moving it over to here, swapping it out with a different cable for the HMI. All of that's going to be controlled over that Ethernet switch. When it comes to installing your S7-1200, you'll notice there's a couple of different methods that we can do. You basically, there's a little clip here. You can latch in the top part of it on a piece of DIN rail. So you have your DIN rail right here. You can latch it in from the top, pull this little clip out, and then once the bottom's on, you can push that little clip back in, and that thing will be locked in and held tight. I usually will put a Phoenix in terminal on each side just to kind of keep it located so it doesn't slide up and down the rail. You don't have to, or a ground terminal or something like that just to hold it in place. You also can do a panel installation too. So these little clips, there's actually one on the top and there's one on the bottom of these little clips, and they have a little hole in them, and you can actually screw a screw right down into that hole, and then that screw can hold it onto a panel. So if you just want to screw it right into a panel, you can actually mount it physically right onto that panel and eliminate the need for the DIN rail. So a couple different mounting options for that guy. The CPU 1214C wiring, as we're going to go to use this. As we remember, our PLC is AC-DC relay. What does that mean? Well, that means we're going to use AC power. So you have L1, you have neutral, and you have your potential earth. So we've got to power the device up with AC. Our inputs are all going to be DC. So you'll see I can use the 24 volt DC that's right on board, or I can supply it externally and then just run the 24 volt DC into the circuit. But what they're showing here is they're showing, look, this negative needs to be connected to M, and then positive, so negative goes to M, and then positive will go through whatever your field signal is, a switch or a sensor or whatever it is, into each one of these ports. So you can kind of see how this guy gets wired up. We also have a couple analog inputs. We'll show you that in a later lecture for now. And then on our relay outputs, we can use relay outputs with AC or DC, and you'll see they kind of signify this. They say either L or N, or plus and minus. You supply that L or N or plus or minus to the 1L screw terminal. Once you do, these 5 relay outputs are all going to be that. So if I supply 120 volts AC to this L1 or this 1L screw terminal, then I essentially have 120 AC available here, 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 and here. I can't make output 0 different than output 3. I can, however, though, if these are AC relay outputs, I could then make these DC relay outputs and have a DC supply on this one. So I'd supply my plus DC here, and my plus DC would come out and go to these different outputs. So it's a little bit different in that these are not isolated relays like some of the modules are for Allen Bradley, where you can have output 0 be AC, output 1 be DC, output 2 be a different level of AC. You know, in this case, if these are 120 AC, they're all 120 AC, and if these are 24 DC, they're all 24 DC. However, I could make these 24 volt DC too. I just got to know, once I do, they're all going to be locked into that particular version. What that means is it means the common for these relay outputs is common for all 5 of these, and the common 2L is going to be common for all 5 of these. All right, data types. This is where we're going to get a little bit tricky compared to the RS500. Most of this is the same. You know, when we talk about a Boolean, we're talking about a 1 or 0. So like a digital input, it's a Boolean. It's a Boolean data type. It's a 1 or 0. We can also have an unsigned short integer is what they call it, an S or a SINT. That's 8 bits. Because it's unsigned, that means we only use the plus side of it. So if you do 2 to the 8, you come up with 256. So our available addresses would be 0 to 255. If I want to use so the unsigned is signified by U. A SINT is a short integer or a signed short integer. And what that means is that in this case, it's still 8 bits. We're still going to have 256 total possibilities, but we're going to go from negative 128 to positive 127. What you guys are used to seeing from Allen Bradley is something called an unsigned integer, which is 16 bits. We said 2 to 16 equals 65, 536. Minus 1 is 535. So an unsigned integer will go from 0 to 65, 535. And if I go to the next level here, an integer will be my signed integer. Still 2 to the 16, still 65,536 or 65,535 as I look at it. And what that means is now I can have negative 32,768 up to positive 32,767. You're going to see a lot more in the world of Siemens because we do deal with 32 bits now regularly. You're going to see the unsigned double integer and the signed double integer. I'm not going to expect you to remember this number, but if you do 2 to the 32, you're going to end up with a really big number of about 4.3 billion. And if you do it as an unsigned double integer, it's going to go 0 to 4.29 billion. And if you do it as a signed double integer, then you get negative 2.14 billion to positive 2.14 billion. So a lot of different combinations. You then have your real number, which is also a 32-bit. This is a 32-bit floating point number. So you'll see it can get really, really small to really, really big. So we're going to have negative numbers of negative 1.17 e to the negative 38 all the way up to negative 3.4 e to the positive 38. And we can have positive numbers 1.17 e to the negative 38 up to positive 3.402823 e to the positive 38. What does that mean? That means you can go from a really big, negative number with a lot of decimal precision all the way up to a really big positive number with a lot of decimal precision. So we're not going to worry too much about memorizing numbers like this. We just want to know that when we're dealing with a real, we are dealing with a floating point number. That's the important thing. A string will be anything I could type in on my computer. So I always tell people a string, a number like 32 can be a string. Something with a symbol like 64 pound 16 star, that could be a string. But also like a password or a name or something like, red cable. That could be a string as well. You can imagine a string as if you can type it in on your keyboard, then we can save it as a data type string. The S7-1200 programming languages, we are IEC 61131 compliant, so we'll see that we have a ladder logic programming language, which is what we'll deal with mostly. We can also, though, program in a function block or a structured control language or a text drill-based language. So you'll see 3 different languages that we can use within the S7-1200 TIA software. All right, when I say TIA here, when you first open up the Siemens software, you're going to see this. It's called TIA Portal. TIA Portal. And what that is that's kind of the interfacing software for what Siemens calls total integrated automation. I think most of you guys are going to actually like this. The reason why is in the past, we've used some PLCs where we had one programming language and one cable for the PLC, a different programming language and a different cable for the HMI, and maybe a third programming language and a third cable for something like a VFD or a servo drive or something like that. What they've tried to do with the Siemens software is do a total integration. What that means is I can program everything from one software for all of my components. So when I want to use a tag in the PLC, I can also use that tag in the HMI. I don't have to reopen a software. I don't have to redo a tag table. I can do all of that from one programming language. So it's really, really, really powerful. And speaking of tags then, I will make a huge recommendation to you as you open up the software and you start working through these job sheets. Use the tag tables. We called this a symbol table in RS500. We'll call this a tag table inside the Siemens S7-1200 software. My recommendation is take whatever names you would have in your I/O listing sheet. As you're going to start wiring up these I/O points, you'll have an I/O listing sheet, which essentially is your wiring diagram. Go ahead, and you know that this start push button is wired up to input 0. Go ahead and go into the software, into the tag table, and call it start PB I0.0, stop PB I0.1, DC fan Q0.0, green LED Q0.1. What you're already noticing as I start talking about these is these are different, right, than what we've dealt with on the addressing. but by addressing these in the actual tag table, we actually will get a clean duplicate of what we see on our I/O listing sheet, what we see on our wiring diagram, and it eliminates the possibility of having the programmer put the start button on I0.1 and the person wiring it up put the start button on I0.0, and then we're troubleshooting as to why this thing isn't working. The program block itself, you'll notice some unique tools that we'll talk about here in the demo in a few minutes. These are kind of the tools where I start out with, but it doesn't look that much different. I've got my start button, I've got a switch, either one of these. I don't know, this probably shouldn't be a stop button if this is an output, right? But you can use these things in the same way we've been working with the previous PLCs. That quick tool is something that's going to be a little bit complex, a little bit a little bit learning curve for you guys to figure out here. Your contacts, your normally opens, normally closed, or as we might call them in the world of Rockwell software, examine if closed, examine if open. Some of your coils that you see here. Your box instructions include things like your timers, counters, all these different things that we've used in other things. And this is where it gets tricky. These are our rung connectors. This takes a little bit of practice, but I will tell you, they actually are pretty handy once you figure them out. So it may take you a little bit of time to figure them out, but in most cases, I actually tend to like the Siemens connectors better than these branch instructions and things that you have to pull in to the Rockwell software. All right, a couple other unique things about Siemens. Rungs, they don't call them rungs. Rungs are called, I don't know how I got call-in, rungs are networks. So when we're dealing with Siemens software, we're going to call these things networks. Each individual rung is a network. You'll see us, we are no longer using the terms examine if closed and examine if open. We now call that normally open and normally closed. So this would be a normally open contact. This would be a normally closed contact, just like you'd expect to see on a relay. Coils are our output assignments, which is exactly what we've seen in the past. Box instructions, those includes your timers, your counters, your math, your compare, all kinds of different things there. And then obviously your connectors allow you to create your branch connectors within individual networks. Notice when we're talking networks, we're using that network term in place of the term rung. Addressing, so S7-1200 addressing. As you look at an input, a couple of key things here. First, inputs will be designated with I's. Outputs will be designated with Q's. And memory addresses will be designated with M's. So you might remember in Allen Bradley, it was I, O, and then we used like B3 for a lot of our binary files and things like that, or N7 for an integer memory address. That'll change a little bit. Most of what we do will be an I, Q, or an M. So that makes it a little bit easier. However, be careful here. Part of the reason why they use a Q is because in Allen Bradley, it can be real difficult to determine the difference between a 0 and an O. So they actually use a Q for the input. If you look at like a Mitsubishi PLC or some other PLCs, they'll use X's and Y's. Everybody's got different syntax, but overall it's the same stuff. All right, first thing in your address here, the I. That signifies as an input, as an output, as a memory bit. The one here, the 0 that you see right here, that's the word address or the slot address. So if I've got a physical module in slot 3, that could be the slot or the word address as we would call it. We have a separator, which is right here. It's a dot. That is our separator. And then this is going to give me the bit. So I0.0 would be the first input word or the first input slot and the first bit within that word. Again, separated by a dot. So right, wrong, and different. It's a little bit, in the world of Allen Bradley, we used I:1/0. One of the things I didn't like about that was they used that slash in a compute instruction. You can't use it for the divide, right? So you have to use the straight vertical for divide in Allen Bradley. So I do actually kind of like using the dot to signify the separator between the word and the bit. System memory and clock bits. So we do have some access to some nice system memory and clock bits. So if you ever want to just address a bit, let's say I want to make an LED flash. Here's my LED over here, and I want to make it flash at a 5 hertz rate or 5 pulses per second. all I have to do is go down here and find out what is that 5 hertz rate. Well, it's M21.1. If I address this as M21.1, that is going to make that LED flash. And I can see what a 1 hertz rate is, so that's very common. I can see what a 0.5 hertz rate is. I can see that's very common. So very handy to have these on. You also have things like a first cycle or first scan bit, an M20.0. Some people like to, hey, on the first cycle or first scan, I want to reset all my timers and counters. So I'll do a reset instruction with M20.0 for every single timer and counter. And then on that first scan, it actually resets them all. So that's a possibility as well. You also have an always high. So if you need a bit that's always on, you can M20.2 or an always low bit, M20.3. Program and network comments. I see I fixed this here. This is nice. Q0.2. That makes much more sense than what it was before. My recommendation to you is when you do this, when you work with the software, go ahead and put in a block title, main program packaging line. Put in some comments, your name, your date, maybe the program revision. So if somebody's looking at your code at a later time, they can actually say, oh, I see what's going on. And then when you get into each rung, let's go ahead and put in some network comments. I should be careful about using that word rung, right? So some network comments also. What is the purpose of network one? Well, it's startup indication. So if someone hits start push button or they hit the switch, I get the red LED. So easy way for you to kind of network these and look at these. All right, so let's get into a demonstration here. If I was going to go ahead and start programming, what I would do is I'd open up the Siemens TIA portal. I'd create the project view. I'd add the device. I'd select the CPU, create the PLC tags, utilize the main programming block to create my program, comment my code as I go, download, test, and debug. So I'm going to go ahead and discard my annotations here, jump out of there, and I'm going to go ahead and close out the TIA portal software. All right, I'll save my current project, I guess. Yeah, always a good idea to save it. And just go down here, I can type in TIA, and you'll see the TIA portal version 13. If I open that up, you'll see Siemens Total Integrated Automation. That's what TIA stands for. TIA portal version 13 is what I'm opening up. And now that I come in here, I see I've got an existing project I can open up, or I can create a new project. I'm going to go ahead and create a new project. And I'm going to call this, what I'd recommend you guys do is go ahead and create a PLC template. So I might call this PLC template file. And then what I would do in the future is, as I go to create a new job sheet or I go to do a new project, I would just open up that template file, because you'll already have all your communication settings, everything kind of pre-set up, so you don't have to reconfigure your hardware every single time you come in. So I've got that going. I hit OK. It's creating the project, or I hit enter there and it went up. It says, okay, we're going to create this project for you. The next thing it's going to do is it's going to say, hey, do you need to configure a device? Okay, I'll go into configure a device and show all devices, add a new device, and I'm adding a controller. I can add my HMI from here as well. For right now, I'm just going to do the controller. I can see, I can go look inside the door of my PLC. I know it's a 1214C AC/DC relay, but you can also, as you go into here, you can see there's 3 different part numbers there. If you open up the door, mine is a 1BG40. 1BG40 is the one that I'm using. I'll go ahead and click on add. And it says good. Yep, I'm going out there looking. Yep, that looks like the one I want. So again, always try, and it actually talks about what it can do, how many communications modules, how many expansion modules. It talks about HMI to PLC communication. So it gives you a little bit of an update. What is it that I'm actually looking at when I work with this particular PLC? Probably could have named the PLC right there if I wanted to. I could have called it Instructor PLC or something like that. The next thing I'm going to do is I'm going to click on this little Ethernet port right here. You'll see there's a little Ethernet port, this little green. It's kind of calling out at you almost to click on it. I'm going to click on it. And once I do, down here, if I open this menu up a little bit, you'll see that I've got IP addresses and different things that I can put in. For the purpose of what you guys are going to do in the lab, you want to make sure that this IP address is the IP address that's on your PLC. So on my PLC it says 10.30.1.98. The other thing you're going to want to make sure of is in your settings for your network. So if you go into your control panel, you're also going to want to make sure that under your network and internet, your adapter settings for TCP IP version 4 Ethernet module, which is I've got plugged in right now. So TCP IP version 4. If I go into the properties, I want to make sure that I'm in that same subnet as what I was looking for before. So my PLC is 10.30.1.98. So I'm going to put my PC, my computer, on 10.30.1.10. Normally I obtain an IP address automatically because I plug into the college's network and it assigns me an IP address so I can surf the network, check email and all that stuff. But when I'm working with the PLC, I want to put myself into the subnet, into this IP address structure that's similar to the PLC. I don't want it to be the same. They can't be the same. They're, it's like sending mail to an address on the same street. It's not the same address, but they're same street, same zip code, and so on and so forth. So the 10.30.1 is all going to be the same. The only thing that's going to change is my PC is going to be .10 and my PLC is going to be .98. So I just want to check and make sure that's the same, and it is. So those are good. So this one's 1.98. My PC was 1.10. I feel like we're pretty good there. Let me move this up a little bit and just kind of make sure everything's kind of looking good. It is. Can I go down here? Oop. Oh, I actually changed that by accident there. Sorry about that. 1.98. That all looks good. I think we're okay. Go back into device configuration here. See if there's anything else I need to worry about. I don't think so. There was a way. Let's see here. I think there's a way to kind of show off some stuff in here as I'm looking. Yeah, there we go. Let's go down. Nothing else down there. That all looks good. That all looks good. Go back to the general tab. That all looks good. I think we're okay here. I'm not too worried about that. All right. So at this point then, I'd be ready to start programming. To actually go in and start doing the programming, you're going to do that within the program block. And you'll see the add new block here. No, not add new block. Sorry about that. I don't need to add new block. I just go to the main. I've already got a block in here I can use. So I don't need to add another programming block. I can just work with my main programming block. Before I do that though, let's go down here a little bit and see the PLC tags. So you've got your PLC tags, and I go to show all tags. I'm going to go ahead and just set up a few tags while I'm thinking about it. I've got a switch on mine, which I'll call switch 1. Switch 1. And I'll do _1. And I can see on my particular address here, that's actually I:0.0. I actually picked that as I:0.0. And it put in as a bool too. I'll put in switch 2. Switch 2 _2. And that'll go in as I0.1. If I want to do an output, I might do, let's say, LED1. Now notice it's going to put it in as I0.2, but I want this to be an output address. So instead of the I identifier, I'm going to change that to a Q, and it's going to be 0.0. So now it's Q0.0, and LED2 will be Q0.1. You can see it kind of defaults to whatever the last thing that was I was working with. I do want to get this underscore in here, so I can just go ahead and plug that underscore in there. So my recommendation is when you get to this point, it'd be a great idea to go ahead and just save the project. Go to File, Save As, or Project Save As. Find a place on your computer where you can maybe save the PLC template, right? So I'm going to save the PLC template. I think I put it in here. Save it. Yes. So now my configuration file, my basics of my IO listing sheet, that's all in there. And then when I want to go to write my first job sheet, I'll actually go to Project Open. I'll open up that PLC template, right? And it's going to bring me right back to where I was. All of those things will be in there again. There's PLC1. Here's my PLC tags that are already in here. If I show all the tags, I can see all the tags I'd already created. And then when I go into my program blocks, I can start programming. But it might, at this point, I might save it as I'll save this as, you know, S7 1200, you know, underscore JS1, and maybe with my initials or something. So now I've got it saved as a different name, saving it differently. It says, okay, that's fine. And now I've got it up and running. I'm like, okay, I've got it saved as a different name, but I can always use that template file as a way to always have my configuration files set, and I don't have to reconfigure my hardware every time. All right, so now let's just talk real basic on how I would go about writing my first program. You can actually see, and I can make this bigger or smaller. I can maximize, minimize windows. So I usually bring this down. A lot of times I'll bring this over because I don't need to see that much of it. And I use these almost all the time. You know, I'm going to click on my network here. This is where I want to work. I'm going to grab a normally open contact. Boom. And if I want to put a contact in parallel with that, what I got to do is I got to go to this left-hand rung and hit this down and over. And you'll see it gives me a little branch rung. And then I can pull down to a little green dot and put a contact in parallel with that. And if I want to go back up, I would click on this and then go back up and it'll connect it. If I want to grab an output, I can grab an output and drag him down here. Neat thing again is I've already created this symbol table. So I can click here and I can say, you know what, I want that to be switch 1. Oh, and this guy down here, I want you to be switch 2. So my selection of my addressing is super duper easy. Let's say that you know, you made this LED 2, but you didn't want it to be LED 2. Maybe it's a different output, Q0.4 or something, right? You can always click in here and type in an address, 0.4. And it says, okay, Q0.4. You'll notice what it did, though, is it put a generic tag on it, right? So it didn't call it what I wanted to call it. So I may want to go back into the tag table at some point and look at that tag 1 and maybe rename that, you know, maybe that's my motor starter or something like that, right? So it's pretty easy to work with. And, you know, I'm not sure. Let's check here. Yeah, as soon as I did that, it went ahead and changed it to the motor starter tag. I don't like for things to be just called tag 1, tag 2, tag 3. It seems to not make a whole lot of sense, right? And then under the block comments here, I could, you know, I could change this to be, you know, this is my, I don't know, motor control circuit. It's actually not going to do anything. This is just a demo. You know, under the block title here, I might put in programmer's name. So if somebody's looking at this later on, they can say, hey, who made this program? Oh, EJ did. You know, what the project is. You know, maybe this is motor control at the ice cream plant. You know, I'm just making stuff up as I go here. And maybe the date. You know, today's date is 2/16/2019. And a lot of times I'll put rev. So this might be rev 001. So if someone's looking at it later on, they can. I can also put network titles. This is network title. I can put a network comment. I can put a lot of different things in here. When I'm ready to download, I'll actually come up to here and hit download. I can put my PLC in run mode. I can put my PLC in stop mode. I can also, using these little glasses here, I can monitor, which is basically an online mode where I can monitor the status of all the bits and watch the thing work. But for that, I think we've got a general consensus. We opened up the portal, we created the project, we added the device, we selected our CPU, we created our PLC tags, we used the main programming block, we commented our code. The only thing at this point then would be to download, test, debug, download, test, debug, you know, and kind of go over this thing over and over again and see how it works. So I hope that was helpful. That'll be a brief introduction to the TIA portal, and we'll get much deeper into the individual instructions and how to work with the HMI and all these other things in future lessons here. Thank you.